back to problem solving, but possibly some of the easier word problems to solve. We will see direct, inverse, joint, and combined variation problems. Let's start with direct variation. You will know that it is a direct variation problem due to a statement within the problem that will say something like y varies directly as x. If this is the type of variation problem you are working with, you will see that as one variable increases, the other increases as well. The equation or formula that you initially create is y equals k times x, where x and y are your two variables, and k is the constant of proportionality. This k will need to be placed in every variation problem, regardless of the type. If y varies inversely as x, one variable goes up as the other goes down. In order to model this, the equation is y equals k divided by x, where again k is the constant of proportionality that we will need to find. If the variation problem is joint, y varies along with more than one variable, perhaps x and z. Let's start by practicing the setup to these word problems. We will state the steps in a few slides, but understand the first step is to create the equation. This is done from the wording in the problem. First one, if m varies directly as m increases, n in turn does. The equation, m equals k times n. Second example, h varies inversely, means as one goes up, the other goes down proportionally. The other variable will need to be down in that denominator. H equals k divided by b. Third example, t varies inversely as the square of b. So like the second problem, but this one requires b to be squared. The formula is t equals k divided by b squared. Fourth example, s varies jointly as r and t, so s equals k times r times t. For the last, there is a direct and an inverse variation. So k equals k times the square root of z over m. Make sure that you can differentiate between the different types of variation problems. If you set up the general equation wrong, you will not get the correct answer. Make sure that k gets placed in the general equation as well. Here is our first problem. Read the problem and then find a phrase that allows you to translate to the general equation. Here are the steps. We write the general equation first. The second step is to find k. You'll be given enough information always to find k, and once you've found k, you're ready to answer the author's questions. We start with earnings vary directly as hours worked. To model the fact one variable goes up as the other does, the general equation is E equals K times H. Remember, K is always thrown into that general equation. Second step, find K. Julie earns $437.50 when she works 35 hours. Substitute these values in to find K. We find K is 12.5. Substitute this in for K. What does K mean? Well, it means Julie gets paid $12.50 per hour for her work. For some variation problems, you'll be able to make sense of K, but for many, especially the more complicated ones, you won't, so don't necessarily worry about doing this. Once K is found and substituted in, you can write the answer, you can answer the author's question. Make sure to substitute the known value for the correct variable. If Julie makes $437.50 for 35 hours, she will make $500 for 40 hours. Moving on, here's a situation where one variable varies inversely as the other. In order to model as one variable goes up, the other goes down, the other variable must be down in the denominator. The frequency F equals K divided by L, where L is the length. The table is my way of organizing the information from the problem. We clearly see the complete set of data that will allow us to find K. Substituting substituting the known set of data to find k. Notice how I wrote 100 over 1 so that I could cross multiply to solve. K works out to be 500. Substitute in and then go on to solve for the unknown. Find the frequency with a piano length of 5 feet. State the final answer in complete sentence. Make sure that you're including your units. Here, one variable varies jointly as the other two. Don't forget the square on the speed. Again, I use a table to organize the information from the problem. Here especially, since there are 3 variables, I use the first letter of the variable. Helps keep things straight for me. Again, once the general equation is set up, your next objective is to find k. Make sure you are squaring that speed value. The constant k works out to be 1/2. Substitute that in for k and then go on to solve for the unknown. Fully and completely answer the author's question. Hopefully this has been helpful, and again, thanks for listening.